This is a review about 7.1 oxidation and reduction. So that was before that oxidation and reduction can be defined in terms of oxidation and reductions, can be defined in terms of gain or loss of hydrogen and oxygen, in terms of change in oxidation number, and in terms of loss or gain of electrons. Gain of electrons. So I'll be focusing on oxidation number right now. So for an oxidation number, you need a periodic table which will be provided to you. So what you have to do before oxidation number, remember any element will have oxidation number as 0, any element in their standard state. Standard state means like hydrogen will exist as a gas, chlorine is a gas, iodine is a solid, any metal except mercury will be a solid, so their oxidation number will be taken as 0. On the other hand, if you have a compound, in that case you will need periodic table, and there are certain rules which we have discussed in the class in detail. So I'll give you a brief about finding oxidation numbers in compounds. You will have periodic table. So this is group 1, group 2. So start from here. Group 1 will have any compound. If it is from group 1, it will have charge of +1 or oxidation number as +1. Then it is +2. Then come to group 13. +3, group 14 ±4, group 15 -3, 16 -2, -1, and then 0. So whenever you have compounds and you have to use a oxidation number, you're gonna use this. Let me take one example. Suppose I have to find oxidation number of let it be MnCl2. All right, so you have to find oxidation number of Mn. So as I have to find the oxidation number of Mn, so I'll assume it to be X, plus oxidation number of chlorine. So you'll go to chlorine. Chlorine is in group 17. So it has an oxidation number of -1 times 2, and there is no charge on this, so it will be equal to 0. Solve it, you will get the oxidation number of +2. Don't think Mn is over here and I can assign the oxidation number. If you are being asked, like you have H2SO4. H2SO4, suppose you have to find oxidation number of sulfur. Don't assume sulfur is in group 16 and it will have -2. Please don't do that. You are supposed to find the oxidation number, and oxidation numbers changes. They are not fixed always. So hydrogen, as it is in group 1, so it has +1, not group 1, just say it is +1, times 2 plus sulfur X plus oxygen, which is here, so it has oxidation number of -2 times 4, and there is no charge on it, so you'll make it 0. So when you'll solve it, you'll get your answer as +6. So this is how you're gonna find the oxidation numbers using the periodic table. Let's apply it. Assign the oxidation numbers to the atoms in the following redox reactions. So first, I would suggest you identify the substance as element or a compound. So you can see strontium is by itself, it's an element. Oxygen is a gas by itself, element. So whenever it's an element, the oxidation number gonna be 0. Now this is a compound. When you have a compound, you need to find out the oxidation number. Just remember, oxygen has always fixed oxidation number, which is -2, except in H2O2. So where oxidation number is -1, that's an exception. So just remember this. So strontium assumed to be X plus -2. There is no charge on this compound, so it's equal to 0. Don't take the coefficients. So X comes out to be +2. So strontium has a charge of +2 and oxygen has a oxidation number of -2. Oxidation number, don't confuse or charge oxidation numbers. I'm assuming it to be the same. Oxidation state. So this is how we will find the oxidation numbers. Now I want you to pause the video and find the oxidation numbers of these elements or compounds. So hope you figured it out correctly. So this is my element. This is also my element. So it's a bromine. I know it exists as a liquid, but it's element. So just go with it's an element. So liquid. So oxidation number as 0 is an element. And over here, cesium and bromine. So bromine, cesium is +1. Solve it for the other one, it's -1. If any element is on the right hand side of the periodic table, right hand side, so you have to try to find the oxidation number of that element. So as you can see, the cesium is on the left side and bromine is on the right hand side. So it's just a small trick from my side. That's not a rule. So I would suggest if you have two elements and they haven't told you to find oxidation number of any, so try to find the oxidation number of the element which is on the right hand side of the periodic table. So when you solve it, it comes out to be this, as this is a compound. So elements, oxidation number 0. When it's a compound, they will have some specific oxidation numbers. So over here, I can take one more thing. As you can find the oxidation numbers, so you can see cesium oxidation number has changed from 0 to +1. So the oxidation number has increased. Whenever oxidation number increased, that's called oxidation. So oxidation number increased is oxidation. Look at the bromine. So oxidation number has changed from 0 to -1. All right. So all of you know this is 0, 1, 2, 3, +1, +2, +3, -1, -2, -3. So you have gone down. So it has oxidation number decreased. So when decreased, or you can say reduced, oxidation number is reduced. When it is reduced, you call it as reduction. So here you get, if you are being asked who is being oxidized or who is being reduced, you have to give all these, you have to identify all these species from the reactants side, So oxidized is cesium. You can ignore the coefficients, and reduced is Br2. So you have to write Br2. Don't miss 2 because otherwise your answer will be wrong. Now look at the next one. Complete the half reactions and determine if it's oxidation number or reduction. I will little bit elaborate the above question. So cesium has changed to cesium +1, all right, and Br2 has changed to Br minus. As we said, this is oxidation and this is reduction. Now in the reduction, you always add electrons on the left hand side. Electrons are on left hand side, and in reduction, electrons are on right hand side. Remember one thing, either oxidation or reduction. So whenever you have oxidation, electrons on the right hand side. So you can see the oxidation number change by 1, 0 to +1. So you will write 1 electron. And the next case, it is 0 to -1. Again, there is a difference of -1. So let me shift my arrow a little bit. So here you go. So electron and it gives you Br minus. Now, importantly, so number of electrons should be same in both the equation. This is oxidation half reaction and this is reduction half reaction. So you split it into halves. So therefore the electrons should be same in both the equations. How you gonna make them same? So there are two bromines. So two bromines, one bromine lost one electron, two bromine will lose gain one. So one bromine gain one electron, two will gain two electrons. So you have to put two here. All right. So Br2 will accept two electrons to give you two Br minus. Over here, now it's one electron. So multiply whole equation with 2. So you will get 2CS arrow, 2CS plus 1 and 2 electrons. So look here, it has 2 electrons, it has 2 electrons. So now the oxidation half and reduction half is complete. Next comes complete the half reactions for the following and determine its oxidation or reduction. So first step is find the oxidation numbers. This is an element. So oxidation number gonna be 0. This is an ion. So oxidation number is +3. So compare. So oxidation number has increased. So this is my oxidation. Now you have to complete the half. As I told you, whenever you have oxidation, electrons will be on the right hand side. So you'll write electron and by how much the oxidation number has changed for 3. So you will write 3 electrons. Next comes Mg2 plus, this is an ion. So first step is correctly identifying the oxidation numbers or states. And this is my element. So element is 0, ion, whatever the charge you see on the ion. Ion means it can be positive or negative. So oxidation number has decreased. When oxidation number decreases or reduces, you call it as a reduction. And in reduction, the electrons are added on the left hand side. All right, so here you rewrite the equation. Mg2 plus changes to Mg. How many electrons need to be added? So 2 to 0. The difference is of 2, so you'll write 2 electrons. In case you have, yeah, that's all. In case you have to write an overall equation using this and this, yes. So what you will do, consider the